Good morning, students. This is Mr. Giomini. Just going to show you, kind of practice two different algorithms for adding and subtracting fractions with unlike denominators. This is something that you may have had some exposure to last year. If I remember correctly, in 5th grade, I believe we do this. But it's been a while now since I taught 5th grade, so I kind of forget. But just in case, a review is always great. So taking a look, the way that most of us are probably used to doing this, the algorithm we are, is finding the LCM, least common multiple, or you may call it the LCM, least common, or LCD, least common denominator. So I look at the two denominators, 4 and 9. Now I usually start with the larger of the two, and I start to list the multiples of it. So 9, 18, 27, 36, 45. And I take that smaller number, I figure out, well, does 4 go into 9? No. Does 4 go into 18? No. Does 4 go into 27? No. 4 times anything equals 36? Yes. So there's my least common denominator, 36. So I'll put my 36. And I like to do it like this. I actually put a larger fraction bar. I put a 36 on top. And then I go to myself, whatever I do to the bottom denominator, I must do the numerator. Let's see if I can say that right. So what did I multiply 4 by to get 9? Or 36, sorry. Well, I multiplied it by 9. So I go 9 times 9 is 81. Now this is an addition problem, so I put plus. What did I multiply 9 by to get 36? Well, I multiplied it by 4. So whatever I do to the bottom, I do to the top. 7 times 4 gives me 28. Denominator stays the same, and I just simply add now. 81 plus 28, which I believe gives me 109. Now, I can simplify this. I'm going to convert it into a mixed number. I believe, let's see here, what is this is doubled, would give me something like 72. If I triple this, let's see, times 3, that gives me 18, that gives me 108. So it would go in 3 times. 36 goes into 109 3 times. The denominator travels with us. 36 times 3 was 108. I subtract, that gives me 1. The way to enter this into con is 1 space 1/36. Oh, well, first of all, let's make sure that mixed number's right. That's 3. Let's see if I'm right. Hey, all right, good. Okay, another one. I'm going to show you a different algorithm for this one. Another way you can do this is just multiply the denominators together. So I'm going to write this. So I could take 9 halves plus 4/5. And you can just multiply these two together and get 10. Now you use cross product. So I'm going to go 4 times 2 is 8 plus 9 times 5 is 45. That gives me, let's see here, 53 tenths, which I like to convert that to a mixed number. 10 goes into 53 5 times. Denominator travels with us. That gives me 10. 10 times 5 is 50. 50 minus 53 gives me 5. 5, and so I put space, 3 tenths. Now, just to show you that I could use the other method as well, the other algorithm I showed you. Let me get rid of all this stuff. So if I take 9 halves, let's get back on pen here. 9 halves plus 4/5. I would first look at the larger denominator, which is 5, and start to list its multiples. 5, 10. Well, I'm going to stop right there because I know 2 does not go into 5, but it does go into 10. So there's my least common denominator, least common multiple. I will put my fraction bar here, or my division bar. I will put 10 as the denominator. What did I multiply 2 by to get 10? I multiplied by 5. Whatever I do to the bottom, I must do to the top. 9 times 5 is 45. What did I multiply 5 by to get 10? I multiplied it by 2. Whatever I do to the denominator, I do to the numerator. 4 times 2 is 8. That'll give me 53 tenths, which I think gives me 5. That gives me 10. 5 times 10 is 50. Subtract 50 there, you get 5 and 3 tenths. So you get the same answer. Alright. I was hoping they give me a subtraction one. Let's try that other algorithm I use, that cross product, I'll call it. I'm just going to multiply these two together. 9 times 8 is 72. I'll put my fraction bar. Now I just use cross product. So I go 9 times 6. 9 times 6 is 54. Plus 8 times 5 is 40. That'll give me 94/70 seconds, which I believe that goes in once. 72 goes into 94 once. Denominator travels with me. 94 minus 72 gives me 22. I see both of these are even numbers, so that means 2 goes into both. So I want to go 1. Let's see, 22/70 seconds divided by 2. That gives me 1. That's 11. Half of 72 is 36. 11's prime, so 11 doesn't go to 36, so that stays. So let's try 1 space 11/36. They are right. I thought it says adding and subtracting fractions. I haven't seen a subtracting one yet. Okay, I'll go back to the other algorithm. Again, I'm just going to flip-flop. You can use whatever algorithm you like. I'm going to tend to think that most of you use that multiplication with the cross product. You have to be careful though when you subtract with that method. If you don't do the right cross product first, you'll get a negative number, and it won't necessarily be a negative number. If I take a look at this, let's see, I'm going to list the multiples of 5. 5, well, 3 isn't going to 5. 10, 3 isn't going to 10. 15, hey, 3 goes to 15. So there's my common denominator. Put my larger fraction bar, division bar, 15. What do I multiply 5 by to get 15? 3. 3 times 6 is 18. Plus, what do I multiply 3 by to get 15? That's 5. 7 times 5 is, what is that, 35. Add these. 15 stays the denominator. Let's see, 8 and 5 gives me 13. 3 and 4 is 1, or 3 and 1 is 4, plus 1, that's 53. Okay, how many times does 15 go into 53? I know that 3 times 15 is 45. That's about as close as I'm going to get. Well, how about I don't use the 4, but I use the 3. So it goes in 3 whole times. 45 minus 53 gives me 8. 8/15. Let's see, the factors of our 8 are 1, 2, 4, and 8. None of those going to 15, so that should be simplest terms right there. Alright, hope that helps you a little bit. Let's see, can I get a subtraction problem, please? Oh, how about this? A negative. Let's throw a negative in this. This is where I'm definitely probably going to continue to use my algorithm where I find the least common multiple. So, my denominator is going to be, let's see here, I'm going to take 9. 9. 18, list of multiples of 8. 9. 27, 36, 45. Well, 5 doesn't go into 9, doesn't go into 18, doesn't go into 27, doesn't go into 30, goes into 45. So there's 45. What did I do to 9 to make it 45? I multiplied it by 5. Now this becomes a negative 40. Plus, what did I do to 9 or 5 to make it 45? Multiplied by 9. That gives me a positive 72. Okay, I see signs are opposite. If I'm at negative 40 on the number line and I add $72 to my account, I have negative $40 in my account right now. It means I overspent. I add $72 into it. I don't really have $72. I really have $32. It's 32/45. Now, this is a tricky one. Can this be reduced? Answer is no. So 32/45. Let's keep our fingers crossed here. Yes. All right. Hope that helps. Have a great day. Bye.